Okay, so going over merge sort in JavaScript, um, just an overarching part of merge sort is just a sorting algorithm. Um, for ints, for example, if we want to call merge sort on this, what we want to do is pretty much break an array into subarrays. So in this case, the next step would be 1, 6, 3. So we get an array of that. And then we would get another array of 2, 4, and 7. But since we still have an array that isn't a single element, essentially what we want to do is get each element to be have an array of arrays with one element in it. So then this one we would break it down into 1, 6. Oops, we don't need that comma. And then a subarray of 3. And this would be 2, 4, and this, as you can see, you kind of get in the picture. And you do this all the way till you have 1, 6, 3, 2, 4, 7, and these all have arrays. You get the picture, so all these would be arrays. And then what you do from here is, let's just, yeah, it'd be nice to have a pen and a mouse, but oh well. What you want to do is compare 1 and 6 and sort it. Yeah, so then you would get a new array of 1. And then once you compare 6 and 3, you get 3. And then you get 6. So this would be your new array. You want to do the same thing for this side. So 2 compared to 4 is 2, and 4 compared to 7 is 4. All right. So and now we got to funnel this down to another single array. So 1 versus 2 is 1. 3 versus 2 is 2. And then, oops. And then 3 versus 4 is 3. And 4 versus 6 is 4. 6 versus 7 is 6, and then 7. And there you have your sorted array. And that's kind of like the general overview of how it works. I think there is a, yeah, I see, it's doing what we just did now. Here, I'll just wait for this GIF to finish here. So now it's just finishing it up. So yeah, here's your unsorted array, and then you want to do is break this down into 2, 1, 2, and then break those ones into 2. And break those into the singular ones. So you have an array of 8 arrays, and yeah, you compare each one. 5 and 6, 1 and 3, 7 and 8. So I kind of screwed up, and yeah, you always just compare adjacent single element arrays to each other. And I repeat the process: 1, 5, and then 3, 5, and 6. This will be 2, 4, 7, and 8. Yeah. Yep, and you get the picture. So then let's see. 1 compared to 2, and then 2 in the front array, the front of the array of each one, grab the smaller one, the front of the array of both ones, grab the smaller ones, so on and so forth. So to implement this in code, first you want to have a helper function called merge that takes two arrays in the left array, like we've always been working from left and right, and merge them together. What we're going to do is just create a new, instantiate a new array called merge array that's empty. Then you want to get the lengths of how many elements are in each one. And we're going to start when we, how we always check. When to merge them, we always look at the first element of the array. So that's what these are. And then, so here's the tricky looping part. So what we're going to do is loop through all of this, both subarrays, and that's like once we get to the very right side, that's the end of it, pretty much. That's what the left and right, that's what that does. We'll do this loop of merging, or pushing the last element to the array in order from left to right, so whatever's smaller. So if the left one is smaller than the right one, the recurring logat, it's going to return this. So this is a turner, and it's just going to push on the left element, index plus 1. So, and if it's if it's false, if rates are smaller, then you want to put on the right front element. And then when you're done, you just you concatenate both of them together. So, and then for the merge sort, it's just the base case. Yeah, so since this is kind of lends itself to a recursive nature of always splitting and then remerging, it can be recursive. So this is our base case of if the array length is equal to 1. So that means when we all split them all up just as single elements, then we're good. Wait, that's not the case, but and then when we split, we always want to split at the middle of how big the array is, so that's the middle value. And then here's the left array and right array. That's how we get them from the middle point. So the very left-hand point to the middle, and then from the middle all the way to the right, the end, which is kind of another way of doing this. This is like -1, like in Python, but yeah, and then you just call merge sort on the left and the right ones until it's all the way to 1, and you just merge them. And that's it. So if you check out this array, what we did in here, 1, 2, 3, 4, 5, 6, 7, I should return that. So let's see here, node merge sort.js. So here's the original one. And then when it's sorted, so as you can see. And then here's a little tester function of, it creates a random array of 10 elements. And it shows them, yeah, so here's the random array of 20 numbers, 20, 88, 99, 98, and here's when it's sorted. So yeah, it's pretty cool. And I think the performance of it is, yeah, n log n is base case, and the worst case is n log n. So it's kind of always consistent with that. Yeah, I think it's just kind of an average sorting algorithm compared to a quick sort, but its worst and worst cases both n log n, so it's kind of nice. But yeah, as you can see by it's merging, so you just want to do is break down all the elements into single arrayed elements, and then you just merge them and you sort them along the way.